An elementary dice problem. What is the probability of throwing a total of 6 points or less with 3 dice? So this is the question. Now you can see that each die can give 6 possible outcomes: 1, 2, 3, 4, 5, and 6. So I'm going to denote by n the sum of the 3 dice. So this is for 1 die. So let's have n denote the sum of the 3 dice. Okay. Now we would like to have a total of 6 points or less. So we would like to have, in order to have n less or equal to 6, we will have, that means n can be 3, 4, 5, or 6. So n is going to be between 3 and 6. Why is that? Because the minimum sum you can have would correspond to each die giving you a 1. So 1 plus 1 plus 1 would give you a 3. So we're looking at the probability of having n equals 3, or n equals 4, or n equals 5, or n equals 6. So whereas in general we have n can take values between 3 and 18. So n can be 3, 4, all the way up to 18, because the maximum you can have is 6. 6 times 3 would give you 18. So as a first step, I would like to look at the total number of possibilities. So what is the total number of possibilities? Well, we would have, let's call this capital N. For one die we have 6 possibilities: 1, 2, 3, 4, 5, or 6. For the second die we have 6 possibilities. For the third die we have 6 possibilities. So the total is 6 to the power 3, because we have 6 equally probable. We're assuming that there is no preference for any face of the die, so 6 equally probable events for each die. So this will imply which are 1, 2, 3, 4, 5, and 6. So these are the possible outcomes. So for one die we can have 6 possible outcomes. For the other die, so let's say that the first die has landed on 1, the second one has 6 possibilities. So corresponding to 1 in the first die, 6 in the second one, we have 6, and 2 and 6 possibilities, 3 in the first die and 6 possibilities in the second die, etc. So you get 6 square, and for 3 dice you have 6 to the power 3. Then I have to consider how many of these events will give me n equals 3. So as a second step, I'm thinking about how many configurations will give us n is equal to 3. So the sum is going to be 3. Well, the answer is basically you need to have 1 in the first die, 1 in the second die, and 1 in the third die. So this is going to be combinations for n equals 3. So out of 3 dice, we're picking one of them. Actually, we're picking none of them, so it's 3 factorial divided by 3 minus 0 factorial 0 factorial, which is 1. So 3 dice, we're picking 3 of them, and they should each be 1. So that's the correct way to state it, and that is basically equal to 1. So we can say we're picking none or we're picking 3 of them. Those are equivalent statements. So what are these configurations? So let's work on a table here. So in order to have n is equal to 3, I need to have first die to be 1, second die to be 1, and third die to be giving me 1 as the output. So that's basically the combinations of 3 objects taken 3 at a time, which are all equal to 1. So this is only one possibility. Now, as a third step, let me ask, how many configurations will give n equals 4? So let's think about this now. So in the second case, we had 1 plus 1 plus 1 equals to 3. For n equals 4, I can have the first one is 1, second one is 1, the third one is 2. So 1 plus 1 plus 2. So basically this 2 can be the third die, it can be the second die, it can be the first die. So basically I'm picking 1 out of 3 dice to assign to it the number 2. So I can say that this is basically saying 2 out of 3 dice should give 1, or 1 out of 3 dice should give 2. So the answer is combinations for n equals 4 is combinations of 3 objects taken 2 at a time, which is equal to combinations of 3 objects taken 1 at a time. So we're assigning 1 to 2 of them or 2 to 1 of them. So this is 3 factorial 3 minus 2 factorial 2 factorial, which is also equal to 3 factorial 3 minus 1 factorial 1 factorial, and the answer is 3. So let's list these in our table. In order to have n equals 4, we can have 1, 1, 2, 1, 2, 1, and 2, 1, 1. So this is the scenario that would give us n equals 4. So for the fourth step, I have to consider how many configurations will give n equals 5. So how many configurations will give n equals 5? Basically, I'm checking what I'm doing with combinations by looking at this table. So in order to get n is equal to 5, if I have 1 in the first die and 1 in the second die, and then the third one has to be 3. And this 3 can travel around. So it can be the first die, second die, or the third die. Another possible scenario, if 1 is the first die, then I can have 2 as the second one and 2 as the third one, and this 1 can travel around, so it can be the first die is 1, second die is 1, or third die is 1, while the others are 2. And these are the two scenarios basically that give me n equals 5. So for this one, basically I'm picking one object out of 3 in order to assign to it number 3, and here I'm also picking one object out of 3 in order to assign to it number 1. So this is either 1 1 3 or 1 2 2, where the 3 and 1 can be assigned to number 1 die, number 2 die, or number 3 die. So 3 1 combinations, 3 factorial, 3 minus 1 factorial, 1 factorial, which is the same thing here, 3 minus 1 factorial, 1 factorial, which will give me 3 or 3. So the answer is 3 plus 3 is 6 possibilities. So let's list these possibilities here. In order to get n equals to 5, I can have 1, 1, 3, 1, 3, 1, 3, 1, 1, 1, 2, 2, 2, 1, 2, 2, 2, 1. So that basically takes care of all the possibilities for n equals 5. And now I have to answer how many configurations will give n equals 6. How many configurations will give n equals to 6? Now let's try. If I put the first one as 1, second one as 1, 1 plus 1 is 2. In order to get 6, I have to put here 4. So this 4 can travel around, so I have to pick 3 out of 1 objects in order to give me 3 factorial, 2 factorial, 1 factorial, which is 3 possibilities for this 1, 1, 4 scenario. Or I can have 1, and then the second one is 2, 3, then to get 6 I have to get 3, so this will give me a 6, and then I can basically have these, so I can pick one of them and assign to it 1, so this basically means pick 1, assign to it 1, while the other 2 can be 2 or 3. So and then when I pick one of them to be 1, then I have 2 possibilities. The other 2 can be 2 3 or 3 2. So 3 1 times 2 would be the answer here. So this is going to be corresponding to 6 possibilities. So you can say basically you're picking one of them and the other 2 can alternate, so you have 2 possible scenarios corresponding to that. So 3 1 times 2, which is 6 possibilities. Or I can have the first one is 2, second one is 2, third one is 2. That would also give me 6. So that only corresponds to one scenario here. So I'm picking all of them and assigning to them number 2. So that is only one possible configuration. Okay, so let's list these possibilities. For n equals to 6, I can have first one is 1, second one is 1, third one is 4. I can have first one is 1, second one is 4, third one is 1, and then 4, 1, 1. That is 3 of them. And I can have 1, 2, 3. So I can say this is 1, 2, 3, 1, 3, 2. Then I can say 2, 1, 3, 3, 1, 2. Then I can say 2, 3, 1, and 3, 2, 1. And the last one is 2, 2, 2. So 2, 2, 2. Okay, so that gives me for 1, 1, 4 scenario I have 3, 1, 2, 3 scenario I have 6 configurations, 2, 2, 2 scenario I have 1 configuration. So this is giving me 10. Okay, so basically if we write this mathematically, I can see that the probability of having n equals to 3 is the number of configurations that give me n equals 3, which is combinations of 3 objects, 3 taken at a time to assign to them 1, divided by, so let's do this nicely here. So this is combinations of 3 objects, 3 taken at a time, divided by the total number of possibilities, which is 6 to the power 3. The probability of having n equals to 4 is you have 1, 1, 2 scenario here, which means you have to pick one object out of 3 to assign to it 2. So 3 objects taken one at a time divided by 6 to the power 3. So this one we have found out is there's only one configuration here, so we can count here. So this is only 1. We can count the number here. This is 3, and for 5 we have 6. For 6 we have 10 possible configurations. So this is basically giving us 1 over 6 to the power 3. This is giving us 3 over 6 to the power 3 as the probability. Probability of n equals 5, as we have found out, is 3, 1. So because we have 1, 1, 3 scenario, or 1, 2, 2 scenario, 3, 1 plus 3, 1 divided by 6 to the power 3, the total number of possibilities. So this gives us 6 divided by 6 to the power 3, and for n equals to 6 we have 1, 1, 4 scenario, which is 3 objects taken one at a time, 1, 2, 3 scenario, which is 3 objects taken one at a time times 2, because we have 2 alternating other 2 dice, and then we have 3 objects taken 3 at a time to assign to them 2, divided by the total number of possibilities, which is 6 to the number 6 to the power 3. So that gives us 10 divided by 6 to the power 3. Now, going back to the original question, what is the probability of throwing a total of 6 points or less with 3 dice? Well, the probability of having n less or equal to 6 means you have the probability of n equals 3. So n can be 3, or n can be 4, or n can be 5, or n can be 6. And so because we have to add these probabilities because it's an or statement. So we have this one, or that one, or that one, or that one. So that basically is going to go through all possibilities here. So we will have then 1 plus 3 plus 6 plus 10 divided by the total number of possibilities, which is 6 to the power 3. So this gives us 20 divided by 6 to the power 3. If you calculate this, the answer is 0.092. So the probability of having n equal to or less or equal to 6 is 0.092. Okay, so we know that each die can give 6 possible outcomes, and I have denoted by n, the lowercase letter n, as the sum of the 3 dice. So we can have, we're allowed to have n less or equal to 6, which means the minimum we can have is each die giving you a 1, which means 1 plus 1 plus 1 is 3. And the maximum we can have in the problem is 6. But in general, we can have all of them coming out as 6, giving us n equals 18 as the maximum. So what is the total number of possibilities when you throw 3 dice? Well, each one can give you 6 possible outcomes, so it's going to be 6 to the power 3, because we have 6 equally probable events for each die, and they're independent, statistically independent events. Now we ask how many configurations give n equals 3. That is basically first die giving you 1, second die giving you 1, third die giving you 1. That gives you n equals 3. That is choosing 3 objects out of 3 objects to assign to them 1. So 3 combinations, that is just 1. How many configurations give n equals 4? You need 1 plus 1 plus 2, or 1 plus 2 plus 1, or 2 plus 1 plus 1. So basically this 2 can be assigned to first, second, or third die. So we can choose 1 out of 3 objects to assign to it 2, or we can choose 2 out of 3 objects to assign to them 1. It's equivalent, and these combinations give us 3. So 1, 1, 2, 1, 2, 1, 2, 1, 1. How many configurations give n equals 5? 1, 1, 3, 1, 2, 2. So for 1, 1, 3, 1 plus 1 plus 3 scenario, we can have 3 can be assigned to the first, second, or third die. So we choose 1 out of 3 die to assign to it 3, and while the others 2 are 1, so that gives us 3. Or we can choose 1 out of 3 dice to assign to it 1, which is in the 1 plus 2 plus 2. So it could be 1, 2, 2, 2, 1, 2, 2, 2, 1. That gives us 3. So we have either 1 plus 1 plus 3 or 1 plus 2 plus 2. So it's 3 plus 3, 6 possible configurations. And similarly, for n equals 6, we can have 1, 1, 4, which means we have to choose 1 out of 3 dice to assign to it 4. That is 3 configurations. 1, 1, 4, 1, 4, 1, 4, 1, 1. 1, 2, 3, we have to choose one of them to assign to it 1. So 3, 1 combinations. And then the other 2 can be 2, 3, or 3, 2. So we have to multiply it by 2. We get 6. And then we have 2, 2, 2. And that's only one possibility. We have one configuration that gives us 1. So the probability of n equals 3 is the number of events that give us n equals 3. That number of configurations is 1. Total number of possibilities is 6 to 3. So 1 over 6 to the power 3. And similarly for the other n equals 4, 5, and 6. And for n equals n less or equal to 6, we need to have probability of n equals 3 plus 4, n equals 4, n equals 5, n equals 6, because these are statistically independent events, and we're looking at the either or statement where we add the probabilities to get the total probability, and the answer turns out to be 0.09